on your test, just to make it clear, there's going to be two kinds of questions on the calculator part. One of the kinds is going to really say clearly, and I try to use the same language or pretty near. It's going to say something like, algebraically, without the graphing capabilities of your calculator, show me how you'd solve. So if all I see is an answer for maximum height, I'm going to assume you did use the graphing capabilities, and you're going to get credit maybe for the answer, but not for any of the work, and that's going to really hurt. So I literally want to see the algebra, and you see that in my solutions on Schoology. However, if it says using the graphing capabilities of your calculator, all I want is an answer. Now, last year, a couple of guys, I think it was Hugh and Michael Mormon or whoever, came up and said, Mr. Hurry, it's so much easier for me to just do the algebra than to sit there and, like you're saying, click, 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 click. And I will show you a better way to get there and then refine it when you're there. Because if you're way down at the bottom and you're clicking on a 0.001 trace step, you're going to be clicking for 10 minutes to get it up there. So there's a better way to get up there. I'll show you. But for those guys, they were like, Mr. Hurry, can we just do the algebra? Like, what's the point in you making us use a calculator if it's easier to know my tricks like negative b over 2a? Or if I want to know, and you can be really exact that way, right? You're not even approximating to 0.001. You're literally being exact. Or like, why can't I just plug in 10 for y if I want to know how long it took to get to that height? And if I wanted to know how far it had gone, I could plug it back in. They literally said it was easier and quicker for them to do the algebra. I don't care. If you want to do that, that's totally fine. They were right, and you might be feeling the same way. But that being said, if you stink at the algebra, and you're like, man, my calculator's kind of saving me on this, because my calculator I can do, but I struggle sometimes with the algebra, just know that on the part that says you are allowed to use the graphing capabilities, all I want is an answer. And I want that answer either accurate to 0.001 on your trace step, or I want it perfect. Perfect would mean like, because sometimes, believe it or not, when you use 0.001, you get a slightly different answer than if you actually use the algebra. Are y'all tracking with me when I'm saying that? Okay, so I'll show you again how I use my calculator to be approximate, how I'll use my graphing calculator capabilities to get there. And this is the way I would get there the quickest. And I'm going to use your homework problem. So projector on. So if you want to follow along with me, if you did do that first homework problem, I'll type that one in. So I am going to clear all the junk out that I have. And just for the sake of starting from scratch, you'll see it up here in a second. I'm going to go to Window Standard, which I'm guessing if this is your calculator, you're not going to be in a standard window, but I'm trying to make it as ugly as possible. There. Okay, so this would be like you picking up a random calculator in a standard window. I go to Menu, Graph Entry. I'm going to put it in parametric mode, and there I am ready to go. But you'll notice, what's my time on? 6.28 seconds. It's kind of a holdover from radian mode. I do want to check my mode on this, make sure I'm in degrees, but it kind of defaults to that, which I don't really love that default, but this 6.28 is not going to be enough time, I don't think, to, or maybe it is on this particular one, but often it's not enough time to get the whole picture in. Okay, so on that problem on the homework number 1, I gave you 110 miles per hour. I won't do that on a test. I won't give you 110 and ask you to convert it and then use it. I might ask you, hey, do a little stoichiometry and convert it, but I won't ask you to use that value in the event you don't know how to do that part. Everything else is wrong. I'm not going to do that. So assuming I gave you what you should have gotten, which is 161.3 repeating. So I'm going to type in these parametric equations. So my parametric equations ended up being, and I'm going to do the best I can with velocity by just putting a bunch of 3's in there. And then it was cosine of 50 times t. And then on the y step, it was 2 plus 161. 1, 2, 3, 4, 5, 6, 7, 8. I guess it really doesn't matter that much. Times And by the way, I like to put times in between these cosines because sometimes it messes up. I noticed yesterday, and I didn't even catch it. Remember when I stored that value for velocity? When I typed it in there, I wrote V cosine theta, and it went from dark V to light V. I don't know if you noticed that. And I went back and restored it. It's because I didn't put a times in there. And I don't know why that it shouldn't do that. When you go 5 cosine theta, it should mean 5 times cosine theta. But this Inspire, for some reason, wigs out a little bit. So what I like to do, anytime I put a trig function in there, I'm going to put times before and times after. And again, I don't know why I have to do that, but I am going to do that just to be safe. It cuts down significantly on issues. I don't want inverse sine. Trig sine 50 times t minus 16 times t squared. And then again, I'm going to go to my theta step, and I'm going to delete out the 6.28 and put something like 30 in there. And then obviously when I graph it, I'm just going to see this line shooting up from 2. And I certainly don't need any of this, right? So my window is junk. So I'm going to go to Window, and I'm going to get rid of Window Settings. I'm going to get rid of all the negative junk, right? I can do that first. And then I need to think about how far out am I going to go? Well, if you've already done the math on this, you're like 800 something feet. But I'm going to intentionally act like I don't know and go, oh, what would happen if it was like 250? That's a pretty big X value. And how high did it go? I don't know, maybe 100. And if I hit enter on that and I get a weird looking graph, just think about it. If I'm shooting up, you can start to see it curve, but if you kind of visualize that, that's going to be really big, right? So clearly 100 high isn't cutting it. And clearly 250 out isn't, I'm not even at the top. So it's going to be way bigger than that. So use your intuition to go in there on your window settings. And by the way, if you say fit window, I know window fit, sometimes you think that'll be great, but remember, parabolas go forever. If you hit window fit, sometimes it'll make just a guess about what you need, but how do you fit it into something that window fit's really more for like scatter plots when you have a bunch of points and you want to get them all in the window. And you'll see that later when we do regression and a little bit of statistics in here. But anyway, window fit's not a great window for you, I don't think. So I'm going to use my common sense and go, all right, I need to go out a lot further, maybe 1,000, and a lot higher, maybe, I don't know, 500, and then graph it. And as long as you can see a nice part of your window, great. You don't have to now try to cut it down to 300 to get it perfect. You go, oh, that's too far, let me make it 800. You don't have to do that. As long as you can see it. I don't know that I'd want a little window like this big. Like somebody in this morning had one, the window was like that tiny. I mean, I'm sorry, the little graph was that small. You can't tell much on that. So make it to where you can kind of see what's going on and you're good. So here's how I would trace now. Menu, trace. Now, right now on this, if I hit enter, it's going to show my cursor over there. And I want you to look at the time. The time is at 6.5 seconds. If I want to get to the top, let's just say, I can, if I'm on trace, I can enter time values and it will jump to that time. So like if I was like, oh, that's not the top, let me try t equals 1 second. I can hit the number 1. You can see it pop up on the screen somewhere. If you hit enter, it'll jump to t equals 1. Well, that's not right, but it's still on trace. You can see it. I can hit 2. That's not it. 3. That's not it. 4. And I'm literally just entering the number to get close. Now that looks pretty close. But when I really look at it, I'm like, well, it looks like it's a little bit too much to the right. So maybe I could even go 3.9. That's a little better. 3.8. That's a little better. Maybe. Hold on, 3.9. Actually, 3.9 is a little better. And the reason why I know it's better, if I'm trying to get to the maximum height, what am I trying to have? And that's the y value. So I'm looking at that y value. Now, once I get close, now it's time to refine it. So at this point, I can move around. Now, right now, when I click left, you can see that I'm moving. Look at the time. It's changing every thousandth. Now, that's what I want to do. But sometimes, like Elle was saying, it takes a long time to scroll on thousands. So if you want, do it incrementally. Like menu, trace, and go to your trace step. Now, I know that you guys with newer calculators have an option for 4. I don't even know what that is. I just saw it today when I was looking at somebody else's calculator, but if you just hit trace step 3, it lets you adjust that. So what I do a lot of times is I get close and then I go to like maybe 0.01, which is not as accurate as I need to be, but I hit enter a couple times and it lets me move every 100th. And I'm going to look at the Y value and get the biggest Y value out of that. Then I'm going to change it to 0.001 and move it around and get the biggest Y value. So right now I'm at 240.639. I'm going to check to the right. I'm looking at 0.639. 635 is smaller, so I'm going to go back to 639. Actually, I lost it. Anyway, 635, I'm going to go left. 645 is bigger. I'm going to go left again. 652 is bigger. I'm going to go left again. 657 is bigger. 658 is bigger. 655 is smaller. So I'm going to go back to that 6.658. That's the highest place at 0.01. Are y'all seeing what I'm doing? Now I'm going to switch and go menu, analyze the graph. I'm sorry, menu trace step. Now I'm going to change it to 0.001. Hit OK a couple times. And now I'm going to do the same thing. I'm going to find the highest Y value there. So at this point, I'm at 240.658. I'm going to try to the right. Well, hold on. 65802, 65808, 65810, 65808. So it looks like the 65810 was the highest value I could get on that trace step. So then I answer the question. If the question was, what is your biggest height? That's it. Based on a trace step of 0.001. Now, it very likely is not the exact value. Because again, being accurate to 3 decimal places isn't as accurate as 4 decimal places or 5 decimal places. So, but I don't need you to keep doing this forever. That is an irrational number. You're never going to get the exact decimal. But I mean, it's government work, right? So we're doing the best we can to get to that approximation. But in all this time, granted, if you're doing it and you have the handle on this, you're going to do it more quickly than I'm explaining it. But just know that I could have just looked at my equation for this kind of question. I could have just looked at my equation and said, you know what, why don't I just do negative b over 2a? Negative b over twice the a, which is negative 16, would have spit out the exact x value the exact time value at that height. And then I could have taken that time and plugged it into my x value. I could have plugged it back into my y value to actually find that height. So I probably could have gotten there quicker using the algebra. But I'm going to allow you to use your calculator if you're like, oh yeah, I can do my calculator well, but all these formulas, this negative b over 2a stuff, I kind of forget it. I'm just giving you 2 options on the graphing calculator part. But all I'm looking at is an answer. And if all you do is trace over there and get close and write it down, you're not going to get credit. You have to be accurate to 3 decimal places, either by the trace step or by using the algebra on this kind of problem. Yeah.
When we do the algebra, we're going to be able to do the math on our calculator, just not use the graphing.
Right. And you could check it with the graphing. I just am going to need to see it. So like if the question was, give me the coordinates at the maximum height, if that's and it was an algebra problem, I'm going to need to see, hey, the t value at the vertex is negative b over 2a. And I'm going to want to see that plugged in, right? So I'm going to see negative 161.33 sine of 50, all of that over 2a, and then equals whatever that time is. And then you would go back and say, and now y at that time value would be 2 plus 161.33 sine 50. And you would take this t value and plug it in there, minus 16t squared, and plug it in there. Heck, I don't even care if you could even do this. AP allows you to name a quantity, a variable. Like you could literally say t equals. And once you get that t, you can write the equation out using that t, and then just give me your answer for your y. AP allows you to do that. Well, it's a pre-AP class. I can allow you to do that. But you got to make that statement and then show the algebra of it. Just writing an answer down is not enough for an AP class. And I'm slowly trying to get you used to that AP kind of language. It's not about an answer, which is really hard for smart people like you because I remember what it was like in pre-algebra and algebra 1. I mean, I know Miss Tyree probably made it a little harder if you had her. But I know what it's like looking at these dinky equations like 2x equals 5, show your work. 2x plus 3 equals 10, show your work. And you're like, I don't need to show my work. And you get in the habit of, because you're intelligent and because you can eyeball stuff, you got in the habit of just writing down answers. I get that. I still see it in my algebra 2 people. I'm trying to untrain them. I got this guy, JW. I don't know if y'all know him. It's a smart dude, man. He just writes down answers. And I know he's smart enough to do that, but I'm trying to get the process out of you, because in AP, 1 out of 5 will be the answer on the free response, which is half your test. You've got to be showing your work and your process. Yes.
Isn't there like a function where you can like open up that thing and it'll show you the max?
Well, on a function, you can find a max, but I haven't figured out how to do it. And it's a great question. Yeah, so if this was a function, like with just y and x, which this is not, this is a parametric set of equations. If it was a function, I could go menu, analyze the graph, max. But this one goes, what graph? And I don't know how to do it. I can't click on it. If you can figure out a way, man, you might save us all a lot of trouble. I just can't. I don't know what to do on this. So there may be, I really do think that there's something I don't know, but I haven't been able to figure it out. I've tried to search on Google, on YouTube, try to find something. Can't find it. So if I could find it, this would all be nice and easy. But I don't know what to tell you. Seems like I just don't know. I just can't get there. Yeah. So that's the problem. If it was a function, absolutely, I'd find the max. Anybody else have any questions on polar? A lot of polar graphs out there.
Can you do one where it's converting from rectangular to polar?
Sure. You can just run through a smattering of things. So what if I gave you something like I'll give you all the ones that you'd have to convert with. I could give you something like r equals 5. I could give you something like theta equals 120, or maybe even something like theta equals 2 pi over 3. How about 7 pi over 6? I could give you something like r equals 3 cosecant theta, and I could give you some of the uglier ones like 3 over 2 minus 5 sine theta. On all of these, your goal is to get rid of r's and thetas, right? Now, you know that r is always equal to what? The square root of x squared plus y squared. So if I make something like this, I can replace that with the square root of x squared plus y squared. And then because I'm going to ask you on your test to put it in this form, that's not in that form yet. But what could I do? Squaring both sides gets me to here. And then I could just subtract 25, set it equal to 0. And that is as close as I can. That's x squared, y squared, constant equals 0. And if you remember on your homework, and I really honestly want to go back and change this, but every time I change something on my key, I have to literally redo the key, rescan the key, re-upload the key to my resources, transfer it over to your class. And so every time I make one small adjustment, it's a 25-minute process. So there are some questions on your review sheet that say, put it in conic form. I'm not going to ask you to do that. So if you can get it to this, great. But I'm not going to ask you to complete the square and tell me if it's an ellipse or hyperbola. I'm not going to. I hope you can look at that and tell me that that is a circle. But I'm not going to ask you to do those conversions on this test if that is a concern of yours. Don't worry about that. I just don't want to go redo my key. Because again, every time I make a small adjustment, And I like to push the envelope a little bit on your reviews, even though I want to test you on that, because you do need to know how to convert. It isn't bad practice when you consider that those are questions that might be asked at a math term. And then on this one, I got to get rid of theta. Well, what was theta equal to? Now, theta is equal to a lot of things, right? I could say cosine of theta is x over r. I could say tangent of theta is y over r, which means my thetas would be inverse trig functions. But I don't want any r's. So what relationship trig function doesn't have r's in it? Tangent. So I can do one of two things. I can use this, right, and replace theta with inverse tan. So I could do that. I could replace that theta with inverse tan. But I just thought, you know what? Why don't I just tangent both sides? Because if I replace this with inverse tan, I'm going to have inverse tan of y over x equals 120. And I'm still going to have to tangent both sides to get rid of the tangent to write it in this form. So on these, like this, I'm just going to tangent both sides. And then say, what's tangent of theta? Y over x. What's tangent of 120? Close? Negative root 3. Now, I got to put it in this form. So what would you do to put it in that form? Multiply by x, slide your x over, and then add it to the other side. So root 3x plus y equals 0. That's as good as I can get it in that form. Right? Yeah.
On ones like those, is it always going to be a certain value?
Yes. Because this would probably be on the non-calculator part. Yeah, and if it wasn't, you would just have some decimal there. Yeah, but on your test, yes, it would be that. And so same thing here. Right here, I'm going to tangent both sides. So tangent of theta, y over x. Tangent of 7 pi over 6 is 7 pi over 6 is just right past 180, right? Right?
Yeah.
And if you forgot unit circle stuff, remember in the third quadrant, it's 1 higher than the bottom. And it's also tangents positive in the first and the third. And then at this point, you could cross multiply if you want to, or you could either cross multiply and get this. You have root 3x, and then just move that over or move this over. Either way, you end up with root 3x minus 3y. So that's a possibility. But I didn't say that you couldn't have fractions with x and y. I just said you had to have x and y together equal to 0. So another thing you could do right here is just multiply by x. And then just subtract that over. Either way, you could have this. And if you think about it, it's the same thing. If I multiply through by negative 3, I'm back to where I was. So lots of different versions here that would be fine. And then when you get to these that have r's and thetas in them, I gave you a process. I told you it's going to be wiser for you if you do what? Now, what are the things I told you to think about? I said, what would you attack first? If there's a fraction, deal with that. And I don't see one yet. I said, deal with the trig function first, the trig function of the angle. And then always deal with fractions as you see them. Like this is a fraction, I'm going to deal with that first. So deal with fractions as you see them. But if you don't have any, deal with the theta part. And again, if you see a fraction out of that, deal with that by cross multiplying. And then deal with the r thing last. Because a lot of times the r part will just cancel itself. Like right here, what's cosecant of theta? And I know some of you have to think through that. What's the sine of theta? Y over r. So what's the cosecant of theta? All right, so if I replace that with r over y, I got a fraction. So what do? Multiply through by y. And at this point, what could you do? You could just divide the r's out. And if I divide the r's out, I get y equals 3, which is the same thing as y minus 3 equals 0. Now, what if it wasn't cosecant? What if it was 5 cosine? Well, if it's 5 cosine, again, if you deal with the cosine first, x over r. Oh, we got a fraction. Multiply through by r. Your theta's gone, your trig function's gone. Last thing, deal with the r. X squared plus y squared. And then, of course, make it this form. I got to have everything equal to 0, so move that 5x over. You're good. And then the hardest of all of them is really more algebra based. It's this last one. So what would you do with this last one? Oh, you got a fraction. Cross multiply. So 2r minus 5r sine theta equals 3. Next step. Deal with the theta part. Sine theta is what? Y over r. Don't forget, these aren't unit circle values. So you can't just put y in there like we had done a lot. It's y over r. Oh, what happens? So I didn't even have to multiply through by an r on this, did I? Now I could have. If I did multiply by an r here, that's not going to kill me. But there's really no need to because these cancel. So now I'm to here. And then what's the last thing I always deal with? The r, if there's any r left. And this is where the algebra comes in. Because when you put this in here, the square root part, this is not in this form. So what do you have to do now? I've given one like this every single year I've taught this class. So move the 5y over and it becomes a positive 5y. Square both sides. Don't forget that when you square both sides, that becomes a 4. And this becomes a regular x squared plus y squared. I'm going to go ahead and have that multiplied out. And then don't forget here, you're not squaring each term. You're squaring the binomial, right? So square the first. That times 2. Square the last. And then at this point, just get it all on one side. So you got this 4x squared. You're going to subtract the 25 from that and get a negative 21y squared. Subtract the 30y. Subtract the 9. And that is now in that form. And if I did ask you, what kind of graph is that? What would you say? To the best of your knowledge at this moment. Looks like a hyperbola because they're both squared, but you got a plus minus. Now, but you don't know that it's a hyperbola because what could it be?
A degenerate.
Nice. It could be a degenerate, but you wouldn't know that unless you completed the square. And I'm not going to ask you to do any of that.
Are you gonna ask us what it is?
I don't think so. No.
Okay.
Trying to play coy like I haven't made the test out and printed it, but anyway, yeah, I have.
Can we go over some of the variations of the weird?
Yeah, absolutely. Pick some.
Kidding.
Yeah, I'd be happy to do all of them except the keys are up, but I can talk about the why of it. But we don't have time, obviously, to do all of them. But. Sorry. There you go. So what key are you on?
The page 55, like the packet that you gave us.
Oh, on the packet. So that's the first part. So what specifically?
Oh, I just thought it's something we could go over.
Okay, well, that's reach. All right, so the first thing on these you need to notice, like when you see, if I were to say sketch the graph, the first thing you need to be able to differentiate is these kind of look like lemon skates, right? Or the Limacon, not lemon skates. They kind of look like the Limacon family because of the 2 plus the A plus B, but you're going to have numbers in front of the thetas. So that's like, oh, this is the weird variations. And these weird variations, I think, kind of fall under the rose curve family, but I haven't found any names for them other than people calling them rose curves. And they'd call these rose curves, but they wouldn't call these starfish looking things rose curves. I haven't heard that. But most of the time they don't call them anything. I won't ask you to name them. But the first thing you would notice is, okay, I do have an A plus B, but I also have an N theta. Then I would do this. What's bigger, the A or the B? And it's clearly the B. And if the B is bigger, is it possible to have negative R values? Now think about it. Sine can be between -1 and 1. So is it possible to have negative R values? And if the answer is yes, then it's going to have inner loop kind of things. Now, what I mean by inner loops, those are the tiny little ones. Sometimes they are inner loops. Sometimes they're not. But it's going to have the tiny petals. So you've got that. It's going to have tiny petals. So that's this. So what you're going to look at is you're going to go, well, there's a 4, like a rose curve. There are going to be 8 petals, but 4 of them are going to be big, 4 of them are going to be small. And I want to know where the first big one is. It's not hard to space out 8 petals. How do you space out 8 petals evenly? You divide 8 into 360, you get 45 degrees, and you're like, okay, they're 45 degrees apart. But I got to know where to begin. So I look back up here and I go, well, when would this be maximized? R has the biggest value when sine is what? 1. On the second one, R has the biggest value when cosine is what? At 1, it's -4. At -1 times the -6, I get 8. Right? So I have to identify where it's maximized. So I'm jumping to this one, number 2. If I find that this R is the biggest when that's a -1, then I'm basically solving this equation right here. So where on the unit circle is cosine -1? 180. So that means 4 theta would have to be 180. But what theta would make that happen? 45. So I go to 45 degrees, and that's my big petal. And if there's 8 petals, they're all 45 degrees apart, right? So 45, 45, 45, 45, 45, 45, 45. Now, that's going to become slightly problematic on problems like this, because, well, not necessarily, because this, we learned with odds, has what? With rose curves. On the regular rose curve, if you had an odd number, you just had that many petals. So with a 5, I'm going to divide 5 into 360. And 5 into 360 goes 72 times. And I'm going to be marking these 72 degrees apart. The only difference is on a regular rose curve, and we traced it and you saw the petals show up, and then what happened? They showed up again in the exact same place. And the reason why you didn't see them is because they were the same size. But on this one, when you see it graphed, the 5 big petals show up, but you do see the other ones. They show up in the same place, but you see them this time because they're smaller. Here, they were always in different places, because that's what happens when you have evens. You see all of them. They're all in different places. Okay? So that's the way. I got to find my first petal, though. So on this one, my first petal ended up being 22.5, using this mentality. This one, 45. This one, 72. This one right here, this would be a -1, sine is -1, -90. Theta would be what, -18 degrees. But once I find that first petal, then I go through there and go, okay, you could, if you want, say, all right, there's 4 big, that would be 90 apart. And then right in between them, there's 4 small. And how do you figure out the lengths? Well, I'm maximizing at what? 8. What's the smallest R can be? -4. But -4 is the same as 4 out, right? So I just go 4 out. Over here, right, I'm still maximizing at 8, those 5 petals, but the other 5 ones happen to be on the interior with the odds. And I know your graphs are different than mine. I changed it. I changed it because I was talking to my 7th period class, and he was like, Mr. Hurry, the way you have the notes, you had sine, sine, cosine, cosine. It makes it look like the sines always have the petals in between, and the cosines always have the petals in the interior. And I was like, that's a good point. It does look that way. So I went back and changed my notes for next year and for your viewing pleasure. But yes, yours looks a little differently, but it has nothing to do with it being sine and cosine. It has to do with it being even or odd. And I think I mentioned the other day, in your brain, if you want to help a way to associate that, remember on even, you see all the petals in different places on rose curves. And on odds, there's overlap, right? Well, same thing here. Here, you see all the petals in different places. But on the odd ends, you see them overlap. They're in the same place, the other set. You just see them this time. So that's when A is smaller. And then when A is bigger, right there, is it possible to have a 0? No, your R can never be 0. Why? Because I can't subtract enough. Look, I cannot subtract enough to make that 0. That means you're never going to hit the pole. And if I'm never going to hit the pole, you literally do the problem the exact same way. You're still going to have 4 places where it's the biggest. you're still going to have 4 places where it's the smallest. So think about it. It's going to be the same thing as graphing big and small petals. You're just not going to graph big and small petals. You're going to mark those same values that you did before. But instead of marking them and drawing petals out to them, you're basically just connecting the dots. So still find the first petal. Where's the first petal out there? When that's 1. Where's that 1? 22.5. There's 8. So they're spaced 45 degrees apart. So there's 1. There's 1. You can do like this if you want. Those are my places where the petals are going to occur. Every 45. But then you go back and you go, all right, big petal at 6 plus 2. Small petal at 6 minus 2, which is -4, or 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. But instead of drawing petals out to them, just connect the dots into some orb-looking thing. And then finally, what happens when they're equal? Then the petal's gone. You're still going to have maxes, right? There still can be maximized. It can be maximized at 8 when that's 1. It can be maximized at 8 when that's -1. So you still find out where that first petal is. So same thing as before. Find out where that first petal is, whether it's there or whatever. Find it. But this time you're like, okay, there's still 12 petals, but there's 6 big ones with a length of 8 and 6 small ones with a length of 0. So they're gone. And that's the only way to make a 6-petal rose curve. Because think about it. How do I make a rose curve with 6 petals? If I put a 6 there in a rose curve format, it would really be 12 petals. This is how you make a 6-petal rose curve. You could also do it with lemniscates, but we won't go into that. Now, this could have 2 answers. Right there, like I can make that graph like this. Does it work? Where's my first theta? When sine is 1, where's sine 1? When 5 theta is 90, that would be theta is 18. Go out 8, there's 5 petals. And if you want to do that or this, totally fine. But if you look at this one and you start going, oh, rose curve. Yeah, 8 sine of 6? That doesn't make any sense. I mean, it would have a petal at 15, but if I write 8 sine of 6 theta like this, it's really got 12 petals. It would look like that. See, I can't make even petaled rose curves with a rose curve formula, although I can do odds. If I graph that on top of that, the only difference is one of them has a slightly skinnier width, but it's nothing I would recognize at all. So anybody at home? Anybody at home got a question? Anyone? What you thinking?
It's a lot.
It's a lot?
Yeah.
Got a lot of review sheets though, right?
Are the 2 related in any way, or are we just putting them into?
We're putting them into one test because I need 3 days to do polar, I need 3 days to do, and it just didn't seem, yeah, because I always do a review day and a test, and I was like, man, that's just wasting another, what, rather than do 1 review day and 1 test, 2 review days, 2 tests, would be losing another 2 days. And normally on probability, I spend 3 days on probability review test, so it's a 5-day. This time on probability, you haven't learned anything. It's a 3-week lesson for me to go back and reteach it. And as many of you, like Cherokee mentioned this too, you guys are going and taking the ACT, and you're like, I don't know jack about probability, except maybe some basic common sense, like what's the probability of getting a king if I draw a card? I mean, some of you can think through that kind of stuff, but you can't think through some of the advanced counting, and you're missing easy ACT questions. So hopefully by the time we're done with all this, you'll be masters of your probability domain, and you'll be able to count and do things like that and a little more uniquely. And you'll be in much better shape. I would think it will definitely matter on your ACT, on your math section.
What's the difference between like the cardioid and the variations where A is equal to B?
So like on this one, this kind of looks like a cardioid, but on a cardioid, on all of the limacon family stuff, cardioids, limacons with inner loops, this number right here is always a 1. It's always a 1. So when you look at all the first 4 we did, limacons with inner loops, cardioids, dimple limacons, and convex limacons, all of those, they're all A and B, cosine, sine, plus or minus, but they all have 1 theta. So when as soon as I start sneaking numbers bigger than 1 theta in there, the variations start happening. What else? I can tell you that most people do pretty well on this, and I can also tell you that this variation stuff, I think there are 2 questions, part A, part B, part A, part B, out of all the questions on this test, which are how many? 24. So 8 points on all of this variation stuff combined. Now the other stuff, polar and whatever, and I'm looking for little things like, are they going in the right direction? Did they find their first pedal? Is the angle between the pedals the same? So even if you like got the one in the wrong spot, if the angles between your pedals were correct, if your length was correct, so you don't get hammered if one thing's wrong with it. I mean, I look at all the different aspects of all of these graphs. So most people do pretty well on this test. I would argue the people that struggle the most, it's on the projectile motion stuff, but I got no trick questions there. I mean, if you can do those worksheets, it will be the same thing regurgitated back to you. All right. Any thoughts? It's hot in here today. How hot? No. When I was in high school, you were not allowed to wear shorts. Anytime. In my junior high, we were not allowed to wear shorts, and there wasn't air conditioning in the building. In Montgomery, which is consistently 5 degrees hotter than Birmingham. We would sit there just dripping on our papers in May, in June. We actually went to June. There was a little fan right here, and it would oscillate. So you'd sit at your desk, like waiting for that waft of air. It would come, you'd be like, and then it would oscillate again. It would hardly push any air around. It was so awful. But yeah, you would just sit there and sweat. Now at least you got some temperature control, you know. Wear some shorts if you want. And leggings, good night. You would have been like thrown in prison for leggings. Back in the 80s.
I was like, I'm better.
Oh, well, we're kind of do this. All this. I might.
I mean, for this sometimes, but I always do my phone.
Like, just because, and they can't wear like